Hello everyone to this video about the combinatorial analysis. In this video we'll talk about the combinatorial analysis and some cases of this combinatorial analysis like permutations and combinations. So the combinatorial analysis is used for counting the number of different ways that an event can occur. So for example, if we take an example about combinatorial analysis. So this example say that there is a college planning committee consists of 3 freshmen, 4 sophomores, 5 juniors and 2 seniors, and a subcommittee of 4 consisting of 1 person from each class is to be chosen. The question is how many different subcommittees are possible. In this example we have 3 freshmen, 4 sophomores, 5 juniors and 2 seniors, and we want to get a subcommittee of 4 person. This consisting of 1 person from each class. So from each class we will have we have just 1 person. So the question is how many different subcommittees are possible. In this case we have 3 freshmen, 4 sophomores and 5 juniors and 2 seniors. The possible subcommittees of this from this committee, subcommittee of 4 persons from this committee will be 3 by 4 by 5 by 2. So we can choose 1 from 3 freshmen and 1 from 4 sophomores and 1 from 5 juniors and 1 from these 2 seniors. So we will have 120 possible subcommittees. The second combinatorial analysis is this permutation. So it is used for counting how many different order arrangements of a group of letters, of numbers, or any group that are possible. For example, in this situation we have 3 elements A, B and C, and we want to know how many different order arrangements we can get from these 3 letters. For example, we can get A, B, C, or A, C, B, or B, A, C, or B, C, A, or C, B, A, or C, A, B. So this is the possible arrangement we can get from these 3 letters. So to compute this is 6 possibles. To compute this numerically, we can say that we have 3 letters A, B, C. If we choose one of these letters, so we have 3 choose. The 2 remaining letters will be 2 letters, so we have 2, and we will choose the remaining, which is 1. So in this case it is 1. So 3 by 2 it is 6 possible arrangements from these 3 letters. And even if we have more than 3 elements, for example 5 letters A, B, C, D, or E, or even some numbers, for example 1, 2, 3, 4, 5, and we want to know how many different order arrangement we can get from these items. It is easy by taking the number of these items and multiply it by the remaining items and by the remaining items by the others and the last one. So in this case we can get 120 possible arrangements. The next type of combinatorial analysis is the combinations. The combinations are used to know how many groups of R elements, we can get from a group of n elements or n items if R is less than or equal to n. So in this case, if we take an example about this combinatorial analysis method, so in this example we have the how many different groups of 3 could be selected from five items A, B, C, D, and E. For example, we can say we have here 5 elements. We can get it by combinations. For example, 5 times 4 times 3 times 2 times 1, which is 120 possibles. But in this case, we will compute the elements that are the same element but with different order, and this isn't the case here. For example, in this case we count A, B, C, B, A, C, and C, A, B, and C, B, A, and A, C, B, and B, C, A. But if we count this all as the same elements, so the same group, this is called the same group. So in this case, the combination of these 3 selected elements will be 5 by 4 by 3 divided by 3 by 2 by 1, which is 10 possible groups. To generalize this method, we can say that we can get from n elements r elements by n minus r factorial. So this expression is called the n factorial or r factorial. So for example, 3 factorial is just 3 by 2 by 1. 4 factorial is 4 by 3 by 2 by 1. So this is the general expression for the combinations, and it is noted by n chosen r. So it is called n chosen r, and its notation is like that.